Hi everyone. Thank you for joining on a Saturday. I think it's Saturday evening there. Um,
Yeah, it's
do
Saturday evening.
apologize. This was supposed to happen on the morning, but I made a couple of mistakes and my time zones are not perfectly aligned right now. But let's get started. I'll try to close the presentation in let's say 10 to 15 minutes, and then we can open it up for Q&A and any other questions you guys have. Um, so let's get started. Okay. Um, Let me just start sharing my screen. Okay. All right. So the way I've created these slides, I just wanted to make this as more of a primer into what data science can offer and what it entails. What it's a very brief overview. I would say there's a lot more devil in the details, and definitely that's something we can discuss if you have any questions related to any of the slides at the end of the presentation. So, in terms of if I was to explain what data science does, and this is, I mean, I've been doing this for a while now, and if I was to give a very simplistic explanation, you see the guy who's doing statistics, which was, I think, well defined and well worked since the 1980s and the 1970s. They put a frame on it, they call it machine learning, and when you present it to a crowd, you call it artificial intelligence. It's a little cynical, but when you get into the field and you've been working in it for about, I have been doing this since, I don't know, 2007, I would say. There was a break in between, but it's 2007. You kind of realize like a lot of it is still based on underlying themes of statistics and calculus and a lot of the stuff that you actually end up doing, even the deep learning aspects which have come in the last, I don't know, 6 7 years are based on linear algebra and matrix multiplication, which you would have done in, in plus one, plus two. So there's a rehash of things. I would say that the math and the algorithms are not as complicated, and they would, if you actually go through each one of them, you would see that there's a lot of similarity what you would have done uh, as part of your, before getting into your undergraduate, as part of preparing for IITs or any other bachelor degree that you would be looking at. In terms of extensive explanation, so essentially, I would say that a data scientist's job, lies on the left-hand side of this. Um, Although I have seen some folks who actually work on both the purple side as well as the dark gray side, and I'll try to explain all of this. This is a little more extensive. So let's say a company comes to you. Let's take, for example, and let's just take the big ones out here. Let's say it's Amazon or Flipkart, and they say that, hey, we have this customer data, we want you to analyze it, and we want you to do this XYZ thing for us. Could be like how do I retain my most valuable customers? How do I get rid of customers who are not adding a lot of value? How do I realize like someone who was high value has suddenly become low value, and so forth and so forth. So all these kind of prediction models that could be created. Like for example, you could even ask that I have this toaster and I want to charge like, I don't know, 2,000 rupees for it, but Amazon, let's say I'm Flipkart and Amazon is charging 2,300, but is that the right price for this? So can I create a prediction model based on that? So there are many avenues where data science can fit in, um, and our job as data scientists is to read what the business is saying and look at the data and try to analyze that. So essentially, typically, and data science workflow tends to revolve around this particular set of three pieces, which is what you would even see as part of any data sciences competition, let's say Kaggle, right? You have feature engineering, you have data which has been taken in, the raw data as it has been inputted on the business side through the applications or through external data sources. That is transformed and binned by you. So, for example, let's say You have data which is 30 days worth of transaction data. So in order to create a standardized format for that, you could perhaps take an average of how much money has come in, how much money has gone out, how many people have clicked, and so forth. So you're taking, let's say, aggregates, median, mean, standard deviation, and so forth. So those are just an example of transformation that can be done on the raw data. Um, and the data could be time series data, text data, NLP data, image data, video, audio, and then you do your feature selection on that. So let's say there are 500 attributes, which is typically what I see in our company, for example. Uh, you wouldn't want to use all of those 500 attributes. You would want to use only a few of those, right? Because not everything adds value to a particular model, to a particular prediction capacity. Some of those attributes would be weak. For example, let's say in the previous explanation, let's say I was saying that, oh, we'll just take an average of all the transactions which have happened, but the average is not really helping out in predicting. And there are ways to figure that out in data sciences, in statistics. So you would not add that as an attribute in the final model. Just an example. If you move on to, let's say, once you have done your feature engineering, and to be honest, the way things are today in the world in terms of data sciences, I think feature engineering is actually the most important thing that a data science guy can do. And that's where the art of data sciences comes out nowadays. Most of us have the same standard set of um, models which everyone runs. So if it was, let's say, an arms race between Model 1 versus Model 2 of two rival companies, the difference would not be in the model that is being used. Let's say it's gradient boosting for just a that's just a simple example of a particular scenario, but let's say it's a kind of model which is called as gradient boosting. The difference in between the good quality data science guy and a bad or other average data science person would lie out here in the feature engineering, their ability to extract more attributes out of the data and then add that to the model to make the model see if it can add any lift or any uplift on existing models which were there, if it can get better prediction capacity. Model fitting does have a lot of options. You have existing algorithms, you have ensemble. Ensemble is what you call as random forest and gradient boosting. Those are actually the cutting edge models for the numerical side of business. You have hyperparameter tuning, which is basically when you come out with ensemble, there's things that can be optimized, parameters which are manual. For example, how many trees do I need? What should be the depth of the tree? So these are basically decision tree systems. But in order to find out the right tree, the right learning rate, you can create a grid search, which will basically go through all kind of variations of each parameter and see which one is leading to the best prediction on the test system. And then the other thing is retraining on a regular basis because the data, if it's changing in terms of distribution. So let's say this is what I typically see in my side of business right now, fraud. So fraud, a lot of folks tend to change their tactics. It's not a stable system where the same guy is trying the same fraud and getting caught again and again. They will try different systems. So the model should be able to understand that tactics are changing and be able to incorporate that into its pattern recognition. And then the model evaluation, cross-validation, you would split out the test and training data into different splits, and you would actually take few of those splits and then verify it against one, and then take some of those again and verify against the previous one, and so forth. You would probably learn that in data sciences if you look into it, and then reporting it to the external stakeholders as to how it's performing. Uh, if it was a regression, what's the usual error rate? If it was a classification, how many false positives do I get? How many false negatives I get? What's based on that ratios such as accuracy, sensitivity, specificity, and so forth. So that's typically where data science likes to be comfortable. But I've seen folks who want to add more, contribute more. They actually work across all three nowadays. Um, Typically, first starting with the dark blue one, where they actually work on deployment as well, and then I'll go through that in the next slides. So in a data science role, talking to business experts, product managers, extraction of the features is uh, quite helpful, I would say. Conducting exploratory data analysis is also very helpful. Taking the raw data, understanding, oh, I should be aggregating this, oh, I should be creating a mean on this or a median on this. That's where the power of the model gets better and better if you add more and more attributes for it to look at. Look at the problem. Is it a numerical prediction like a regression? Is it a labeling problem? Do I need to find out whether this is an apple? If that's an orange, that's a classification problem. Or an optimization problem, which is basically, I think, where the future is headed. There's a lot of work that has already been done in numerical and labeling. I don't know if we can get better in that in terms of our algorithm abilities, but I do see a lot of uh, growth happening in optimization, especially in reinforcement learning. That's something you guys can pick up on, and we can probably talk about that. Looking for the right model. So, for example, let's say it was a numerical one, which is regression. Do I need to use the simple linear regression? Is that good enough? Do I need to go for elastic net? Do I need to go for ridge, lasso? Do I need to go for gradient boosting, and so forth? So a lot of options can be there based on the kind of problem you need to solve, based on the nature of the data, and so forth. And yeah, you solve for X, you solve for the problem at hand, and you provide those same results to the external stakeholders. So easy peasy, and that's a very short form, and that should do it in a very beginning role. But as you get further into the business, it doesn't really stop at that point. You have to bring the model to production. And I'm so sorry. What I mean by that is the ability to not only show it in the batch form, like, oh, by the way, we found this model and it works well out here. I mean, that's great. But if you're part of an engineering business and you're part of a tech business, you need to make it part of a production business, which can handle it at real time, offer some sort of um, prediction at real time, and say that, hey, this user, I think this user is a high value customer. I think this user is a low value customer. And then, let marketing or let retention account management make scenarios on top of it that, okay, there's a high value customer according to data sciences. Let's give this guy 10% off. If this is a low value customer, let's, show him an ad and try to make money on him because he's definitely not looking to buy, and so forth. Um, so yeah, bringing it to production is definitely where you add a lot of value. You have basically what you're saying is data sciences, the model itself, it's become quite stable. It's become quite good in terms of prediction. I think we should be putting it in production and basically trying to optimize the user experience or trying to optimize whatever problem you're trying to solve. This involves obviously making the model available at real time. And in today's world, real time is a bit of a, so there's a couple challenges there, which is where the growth is happening nowadays. Another area of growth, apart from the optimization issue I mentioned, this is where we are, at least as engineers and data scientists, we are all trying to do two things at the same time. We are trying to create models which work on big data, which are able to take 1,000 attributes at one go, but also make sure that this 1,000 attribute system can handle at real time. It can actually work in and give a prediction back in, let's say, less than a second. So there's quite a few. So if a company is looking for that kind of real time behavior, and there are companies who do that, then there's a lot of growth which is happening right now there because there's we haven't solved this problem yet, and there's definitely some work to be done there. Which so let's say your company is good in this, and it's created this kind of a microservice model where the model is acting as a small server. So yeah, the model acts as a service at this point. So you just pass it the features that, hey, I have these 5,000 features, and here's the prediction that is coming back from the model. And the model acts as a small, let's call it as a web server, and it just absorbs the features, and then it spits out the prediction as to, what's the right price, whether this is an orange, whether this is the high value customer, and so forth and so forth. Okay, so what's my background? I have a bachelor's from NSIT. I did my MSc in computer science, USC. That was some time ago. Actually, that was 2005 to 2007. At that time, AI was not AI. I used to consider AI to be my research, not adding any value to me, just doing it because I liked it. And then I stayed here and I shifted back to India, I would say around 2009. Did my MBA out here. 6 years in finance, Goldman Sachs, IFL's investment banking in Bombay. 6 years in computer science, Microsoft, and recently 24/7. And now I handle fraud for Cabbage, and I'll probably be handling data science product management as well. Um, all of that. I just want to give a caveat. You don't need to have the same credentials. I'm not saying that you need all of this to be a good data scientist. You can probably cancel out the MBA. There's probably not a lot of need for that. I work in product, that's why I have an MBA, but you can be a data science guy and not have that. It's helpful to have an MSc, but if you're a good bachelor's and you have actually, I've seen that many folks who come out from the bachelor's are decent, and they learn on the skill sets. And yeah, a couple years down the line, they're as good as an MSc, so maybe not needed. But yeah, the very nature of a good data scientist guy is to have the right tool set and desire to see the data science as a puzzle, and see the data, be happy to explore it, be happy to work with it, and try to optimize it again and again as much as possible. Because even a 0.1% improvement sometimes can lead to, I don't know, $10,000 in saving for some company somewhere. So yeah, you definitely add value to the bottom line, and they obviously see a value in you as well in such cases. Tools to know, you would want to know statistics, which is I would say a lot of that you would have covered already. If not, then you should probably cover that. Um, and it should be similar to what you've done in plus one, plus two. Optimization, linear programming, and genetic have been the old systems. There are more systems out there, but these two have been there since the last 20 years. So that's definitely the first thing in optimization. Support vector machines, Lasso Ridge. Support came out about 20 years ago. It was the market leading system for about 15 years to 10 years. But with deep learning coming in, gradient boosting coming in, I would say that it's a nice to know thing, but not so important. Lasso and Ridge are definitely important, mainly due to the nature of many systems unable to handle gradient boosting and other more expensive options, and then they would want to go with this, which is okay. Ensemble techniques, random forest, gradient boosting. These are the market leaders at this point. Random forest used to be the market leader for a long time, till gradient boosting came along about 10 years ago. And today's most Kaggle competition winners are using gradient boosting and a variation on gradient boosting, like XGB, CAT boost, etc. Those are the ones which are definitely winning the games and definitely winning the competitions. Bias variance conundrum. So that's the very nature of data sciences. So most of the old systems, except for Ensemble, I would say, and Lasso and Ridge, they have this issue where you can have high bias ones and low variance in the test, but have the other way around works in some other models where you have low bias and high variance. Bias is where you train and it all looks good, but when you see it in the real world, it goes shitty. So that's high variance. So you want to handle both of them. You essentially want to keep both of them low. Very few models can do that. These ones on the right hand side, these are the ones which have been good in that. Right. Deep learning. Deep learning is specifically meant for continuous data, unstructured data. And the three places where it's currently used a lot is first text, second is I would say the image problems, and third is video. And that's where you start talking about someone like YouTube, how to find out if a particular video is disturbing for the viewers and automatically realizing that and deleting it as quickly as possible. Python and R are your languages through this. I would say Python is should be the first go-to, but many people when they start, even me, when I came back into data sciences, I started with R. But Python is such an easy language that it should be a really quick, fast way to get in board and learn it. Potential. There's definitely a lot of potential, and that's mainly due to this data points thing. Um, there's a lot of stuff which is happening, right? So if you realize, like, we are currently in 3G and 4G networks, we're going to be moving into 5G in, let's say, another 5 years. A lot of stuff which happens. So just to give you an example, that's not mentioned here. 5G, the difference is about that its speed is about 10 times the speed of 4G. So if you were to watch a movie today, it would take you like, I don't know, probably 10 minutes maybe, or 15 to 20 minutes to download it on a 4G network. In a 5G, it will take you about 3 minutes probably. Or even I've heard of some places they might just be able to do it in 30 seconds. So what does that mean? In terms of, I think what's happening right now is that uh, two, three things are happening. We are getting more data from smaller devices, mobile, video, and other IoT devices, and that's definitely feeding into these centralized data platforms that we were talking about, right? Earlier. So if the raw data is coming, there's a lot of work that needs to be done in terms of just classifying that data or reading through it at real time and saying that, hey, by the way, this is an issue. Let's fix it immediately. Which could be both. It could be numerical data, it could be unstructured data. I do feel like the way things are going with mobile sensors, maybe it's numerical, with video, just the nature of video itself. It's definitely something which deep learning will fix. And yeah, people are adding more to social networks. Stock market, I do see like people have been trying to fight with data science for a while. Not sure if things are working out there, but I have seen some good ones for longer term portfolio investments. Reading smart grids, smart meters every 15 minutes, and so forth. And genome sequencing, that's like something which is just coming up. People have started looking at machine learning and seeing how we can create better drugs at cheaper prices, being able to find the right kind of molecules within days instead of months. So you can imagine the kind of quality. What you're basically saying is that you can actually beat a Nobel winning physicist in this business, which is pretty amazing. Certifications, packages. I do feel like most undergraduate postgrads are not teaching this in terms of math, and I don't blame them. It's just a recent phenomenon. We obviously will adapt to the problem. This is basically linear algebra and data science and calculus. So I do see maybe places where we're doing matrix multiplication start aggressively expanding into deep learning. Any place which is doing calculus also look into gradient, stochastic gradient descent, which is basically another deep learning system, and also for the same formula for ensemble methods as well. So yeah, suggestion would be to take a short duration course, goes through the rigors of data sciences, I have talked to a couple people. I've actually seen this in Bangalore at least. I do feel InSoFe is a pretty good program. So most of the professors out there, I do know them. I do feel that's a good place. But you're obviously free to see what kind of place you're going to, but definitely see the kind of quality of education you're about to get for your money. Salaries can be comfortable down to 20 lakhs for, let's say, an entry person who's looking to do batch level prediction versus someone who's doing real time prediction on a big data platform, has experience of 5 years under the belt, doing the same thing again and again. And that's like, 50 lakhs and so forth. But I could be wrong. I think Arham would probably know this better in IM jobs rather than me, and these guys probably know more about the salary packages. And yeah, that's it from my side. I guess I've been talking for a while now, so let's open it to questions. I know I've taken a lot of time, but thank you for your patience and so forth. And let me know.
Thank you so much, Puneet. Let's open up for Q&A. Can you see the chat with all option, Puneet?
Yes, I can.
Yeah, so they have some queries, I guess.
Uh-huh. Give me a second.
Sure.
Can you share this presentation? Sure, I can send it to Arham after this, and we can probably take that. Definitely.
Sure.
What do employees expect from a data analyst at entry level? I do feel this is where folks. So you've got to understand when you're coming in at an entry level, they don't expect a lot. You have to prove yourself that, hey, I want to take more challenging work, as you would expect in any company, in any business, be it business management or product management, etc. To prove your value, you have to do more and be willing to take more work. So typically, what happens? They will ask you to look at this data, do some analysis, garbage in, garbage out, and and provide that input and output to them. You may screw up a few times. You'll get the hang of it slowly. Like, okay, I need to be doing this, not to make the same mistake again and again, and you'll probably get better at it. Eventually, you'll get bored by it. Then you'll ask for more work, and then they'll give you more work. So typically, initial work is just analyzing the data as per what they want, which is, let's say, see central tendencies, or to create bar charts around it and see what the data is, which is also not bad because it gives you an experience in EDA and exploratory data analysis, and makes you an expert in that when you come to actual data sciences. I have 19 years experience, 10 years in management. I've done That's good. In terms of subject knowledge in R and Python, hang on, I'm getting. Oh, okay. So that's the Kanan thing. Okay. Um, okay, Kanan, I'll handle your question. So let's handle that later a little bit. In terms of subject knowledge in R, I'm getting multiple questions in 1 second. Hang on.
So here Viraj is asking that in terms of subject knowledge in R and Python.
Mm-hmm.
So does that Viraj, can you be please more specific about what you are asking?
No, I don't know if she's still there.
Yeah.
Okay. Um, but I think I can address that for the overall audience. You R is kind of the entry level language, I felt. It's an easier language to work with. R Studio has a lot of help around it, which makes it easy for people to work with it. I've also seen that there's a lot of community work. You can search in Google and find so much in terms of, like, okay, I need to make this model work, or something is not working. How do I make it work, and so forth. But the reality of R is that it's a single-threaded platform, which means that if your laptop, for example, had 4 chips, it would only work on 1 chip, and it's a little unstable. So when you come into these other models, for example, in deep learning, it will definitely not work. In fact, they themselves are well aware of the fact that they're not great in it. They actually allow for connection with other systems, but it's just easier to work with Python on that side. And if you work with an ensemble, etc., like gradient boosting, it's definitely if you were to put that in a production environment, people will ask you to put it in Python. So I've usually felt it's just better to do my work in Python from the beginning, just to make it easy for myself later. Okay. What knowledge? Okay, hang on. So at entry level for data sciences, can you suggest any good books for interview? As you can see, most interviewers are going deeper in statistics. That's a good point. I would say that that's true because of a couple reasons. I would say one thing which I've seen is that not everyone is comfortable with deep learning. It's a new technique, right? So people are going to focus on what they're comfortable in. That is statistics. And statistics has been there for a long while, so there's a lot of questions one can ask on it. And to be honest, it's a the very base of a data science guy. If you don't know statistics, you will falter at some point by making the wrong assumption, even if the model and everything else is handed to you. Um, in terms of understanding, I've so when I did this in, I would say probably 08, 2008. Um, I think there was a book called Multivariate Data Analysis, Multivariate Statistics. I don't remember who the author was. That was a really good book. I would suggest that, and you can probably find that somewhere. Multivariate Statistical Analysis. That is what I think the name was. Okay. Um, for data, hang on, just one sec. What do employers expect a data analyst to know uh, in terms of subject knowledge in R and Python? Um, they depends. I mean, depends on the role. If it's data analyst, entry level, batch level data ad hoc analysis, they're probably going to ask you an hour, some questions maybe, just to see what your quality of work is. If it's Python, then they can ask you, how do I make Keras work? Keras is a library for deep learning. If it's deep learning, how do I put this into production? They may go into details in terms of engineering pipeline for Python. For data science role, also, what knowledge do companies expect at the time of interviews? I mean, they are going to ask you right from the basic statistics to more advanced concepts in deep learning, perhaps depending on what you're applying for. So it depends. I've seen entry level. This is obviously a discussion on entry level. I think statistics is where they will go. They will ask you up till regression, logistic regression, reg, lasso. How is reg and lasso different from the usual regression in terms of bias variance? Um, they may go into a lot of statistics, binomial, um, and other kind of distributions which come up, right? So they can ask you variations on that. What kind of salary can an entry level professional expect? Probably 10 to 20 is what I think it should be on an annual basis, but I could be wrong. Uh, Kanan, I do not have real-time experience, only post-related. What has the opportunity to get into data science field? I have goods on. I mean, I think it's great that you have a good hands-on knowledge for Python. Kudos to you on that. I do feel what you can possibly do is to look for rules which are, um, it depends on what you want, I would say, given your experience. If you're looking for to get back into an entry level system, get hands on, then I'm sure there's a medium tier like a tech lead or a data science lead type position for someone like you. And they can probably get you into something like that. I think that's one of those options where you can work, Kanan. Uh, But yeah, you can obviously send me an email later, and maybe I can help you out with whatever your current um, scenario is. If we update our skills, data science with BA would, yeah, I think so. I think it would be an added advantage. Business analytics. So are you saying that data science existing or and then add BA or BA? I think you probably are talking about BA first and then DA.
Yeah, hi. Uh,
Hey, Sohan.
yeah, so what I was trying to mention was like whether, I mean, I have currently done my data scientist course, and I would like to update my skills with the business analytics. So would it help me? I mean, would it be a added advantage while I'll be serving in the company?
Depends on the BA course which you're looking at. I do feel a lot of them will have overlap with if it was a good DS course taught you statistics, I think it would there may be a chance that a lot of that internal central tendencies, mean, medium, standard deviation may come back again in this course as well. Then you would, uh, with all respect, you might just be wasting your money there. But if it's a different aspect, um, then the coursework, the content is different, then yes, I think it would definitely be a useful thing to look into. Okay. Project management, 15 years, but not into development or data sciences. If you've been doing project management, one thing that data sciences seems to be having a problem with nowadays is the ability of data sciences to actually execute things. So what I mean by that is, um, a lot of times data science teams have problems where, because of the nature of the work, it's a lot of R&D. You have to look at the data again and again and again. It's not engineering where you are creating deterministic systems. You know what the data is, you know what the output has to be, and you basically execute it, right? So, and just give me 1 second, please. Yeah, sorry about that. Okay. So I do feel like the challenge has been for data sciences that because of the R&D nature, they have issues in terms of executing things. I think that's where a project management person can definitely come in. Although that being said, I would say that um, that is only happening in advanced data science pipeline scenarios where people have been doing data sciences for about 5 years in the company and they have started realizing that um, they are facing issues with deliverables not getting done on time in data sciences. It's just the nature of the R&D work. R&D doesn't work strongly with timelines. It needs its own time, and then making that work with project management is something that could be possibly useful in terms of data sciences. So just to trying to combine your pre-existing experience with data sciences.